Welcome back to Applied Physics Lecture Series, Unit 4 Fiber Optics, Lecture 9 Types of Optical Fibers. What are the different types of optical fibers are available? So, we are having three types of classifications or three types of optical fibers. So, based on the different criteria into the consideration. First criteria, based on mode of propagation, optical fibers are divided into two categories: single mode propagation, multi-mode propagation, or they may called as single mode fiber or multi-mode fiber. Second way of classification is based on variation in the refractive index of core region, which is represented with N1. Optical fibers are divided into two categories. First one is step index fiber, second one is grade index fiber. Coming to the third way of classifying optical fibers, based on material used for manufacturing of optical fibers. Optical fibers are divided into two categories. First one plastic fibers, second one glass fibers. Now I will explain all the three different classifications in detail. First classification based on mode of propagation. So optical fibers are divided into two categories. One is single mode fiber or single mode fiber propagation. Second one is multi-mode fiber or multi-mode propagation. What is meant by this mode? Light launched into the fiber within the acceptance cone propagate through it by total internal reflection. But only one light which travel through the fiber in a particular direction is allowed, which satisfy the condition of constructive interference. That light rays are traveling in these specified directions are called as modes. Or simply, if you want to define what is meant by this mode of propagation, the number of paths that are available for the traveling of light ray in the core region of the optical fiber will be called as mode. So what are single mode and multi-mode fibers? If the thickness of the fiber or diameter or width of the core region of the optical fiber is small, that supports only one light ray for the propagation at a time, that means it offers only one mode, then it called as monomode fiber or single mode fiber. You can able to see this see this single mode or monomode fiber in this yellow diagram represented at the bottom here. And the second one is if the fiber supports more than one light ray to travel in the core region of the optical fiber at a time, or it offers more than one mode, then it is called as a multi-mode fiber. See, more number of light rays are traveled in the same core region of the optical fiber at a time, which is represented in the above diagram. So that is about single mode and multi-mode propagations or single mode and multi-mode fibers. And what are the basic differences between this single mode and multi-mode fibers? Single mode fiber has a small core diameter, typically it is around 2 to 8 micrometers and can support only one mode of propagation. But whereas multimode fiber has a large core diameter, typically it is about 50 micrometers and it can support number of modes. And in case of single mode, launching of light into the fiber is difficult, whereas in case of multi-mode, launching of light into the fiber is easy. Fibers, third one is fibers can carry information to long distances. As a result, dispersion of signal is less. Fiber can carry information to the short distance only. In case of multimode fiber, as a result, dispersion of signal is more. These are the basic or important differences between single mode and multimode fibers. Then coming to the second way of classifying the optical fibers, so that is based on the refractive index of core, we are having two types of optical fibers, step index fiber and a grade index fiber. What is this step index fiber? In these fibers, the refractive index of core is uniform. Core is uniform over a certain distance, and slightly it will undergo a sudden change in the form of a step. That means it is slightly more than that of cladding. Then that type of fiber is called as step index fiber. Here the refractive index of core is varies over a distance in the form of steps. That's why it is called as a step index fiber. Intermodal dispersion or pulse broadening occurs in this type of fibers. Then coming to the grade index fiber. In this fiber, the refractive index of core is made to vary radially. That means it has a maximum refractive index at the center and which will move gradually towards the outer ends of the core diameter. So whereas radius is increases, refractive index decreases. That means at the center of the optical fiber, refractive index is maximum, and at both the core diameters, refractive index is minimum. At the core cladding interface, the refractive index of core and cladding are same. That means at the two ends of core diameter, that means core clad interfaces, the refractive index is same. Pulse broadening is overcome here. in case of gradient index fiber. And how the propagation of light takes place in case of step index fiber and gradient index fiber. In case of step index fiber, it offers both single mode as well as multimode propagation. Here I will explain how the multimode propagation takes place in case of step index fiber. Similarly, the bottom diagram represents the propagation of light in case of multimode gradient index fiber. Here gradient index fiber offers only multimode propagation. Single mode propagation or monomode propagation is not existing in case of gradient index fibers. Then see here how the transmission of signal will be takes place in case of this step index fiber. Observe this diagram. The central region is a core region. In the core region, two light rays are propagated at a time. So those are represented with path 1 and path 2. See that a pulse travels through step index multimode fiber. The pulsed signal travels in different paths, path 1 and path 2. At the receiving end, the ray traveling along path 1 reaches first, while the ray traveling along path 2 reaches with a little bit delay. Hence, the pulsed signal is received at the destination is broadened and it is called as intermodal dispersion. Intermodal dispersion can be overcome by using gradient index fiber. Then, let us see here how the signal will be transmitted in the gradient index fiber. Again, in this diagram, you will observe the two paths. First path represented as path 1 is traveled in the refractive index higher region, and path 2 is the light ray which is traveled in the refractive index is lesser region. So let us signal pulse travel in the two different paths, path 1 and path 2. The pulse traveling along path 1 travels less distance but in a medium of higher refractive index. See here, path 1 is traveled less distance because it is almost traveled axially along the axis of the optical fiber, but it is traveled in the medium of higher refractive index. And the pulse which is traveling along path 2 travels more distance but in a medium of lesser refractive index. Observe here, it suffers with the maximum total internal reflection. That's why it is reached to the core clad interface. That's why it is traveled much distance, but more distance, but it is traveled in a medium of lesser refractive index. Hence, both the regions, both the light rays traveled in path 1 and path 2 are reached the destination at the same time, and pulse broadening is overcome here. And we are having two types of rays, meridional rays and skew rays. What are these meridional rays and skew rays? A ray that propagates to the core of the fiber undergoing total internal reflection is called as meridional ray. A meridional ray always crosses the fiber axis. Once this type of meridional ray interacts with the core clad interface, a sharp total internal reflection takes place and it will reach to the other end of core diameter or core clad interface. Again, sharp total internal reflection takes place. This type of light ray always crosses the fiber axis. Such a type of rays are called as meridional rays. Such a rays are propagated, traveled in the core region of step index fiber. Then another type of rays are skew rays. Those are described as angular helical path as they travel along the optical fiber. So it is not crosses the optical fiber. It is traveled around the axis of the optical fiber, very near to the core clad interface in the path of a helic, in the path of a spring like that. It is shown in the diagram 2. So the type of rays are propagated in the gradient index fibers. Then what are the main differences between step index and gradient index fibers? In case of step index fiber, refractive index of core is uniform throughout except at one stage. But in case of gradient index fiber, the refractive index of core varies gradually with the radial distance. And in step index fiber, it supports two types of propagations, both single mode and multimode propagations are possible. But whereas in case of gradient index fiber, it supports only multimode propagation. And usually step index fibers are used for short distance applications, whereas gradient index fibers are used for long distance applications. And in case of step index fiber, attenuation losses are in the order of 100 decibel per kilometer, which is usually high. But in case of gradient index fiber, attenuation losses are only in the order of 10 decibels per kilometer, very less when compared to the step index fiber. In case of step index fiber, meridional rays are allowed to travel. That means meridional rays propagation takes place. But in case of gradient index fiber, skew rays propagation takes place. And step index fiber manufacturing is very easy, but whereas manufacturing of gradient index fiber is somewhat difficult. Then coming to the another classification of optical fibers based on the material which is used for the manufacturing of optical fibers. So based on that material which is used for the manufacturing of optical fibers, we are having two types of optical fibers. First one is plastic fiber, second one is glass fiber. What is this plastic fiber? These plastic fibers are made either entirely from plastic, that means both core and cladding materials are made up of with plastic, or sometimes some silica core and plastic cladding. Core is manufactured with silica and cladding is manufactured with plastic. And full plastic fibers, if you are using, they are suffers with high attenuation. Losses are more in case of full plastic fiber. And the plastic fibers are used for short distance applications, so which is around 100 meters. And these are also used for low bandwidth systems in the wavelength range of 600 to 700 nanometers. Example, polystyrene, and it can withstand temperature up to 70 degrees centigrade. Then other type of optical fiber based on material which is used for its construction is glass fibers. Usually those are made up of silica. They are used for long distance communication and withstand to the temperature of about 400 degrees centigrade. So chemical resistance is high in this type of fibers, and attenuation losses are minimum here when compared to the plastic fibers. Thanks for watching.